agenda today. We have 3 topics that are set up, and then if we have time, we can open the floor towards the end. First topic is from Palash, who's also the first time. He's presenting Rapido's journey with Amundsen. The second topic is user learnings related to data lineage, which Daniel is presenting from Lyft. And then the third topic is a demo of Lineage and Atlas, which Verdan would be presenting from ING. So without further ado, I'm going to pass it on to Palash to talk about Rapido and Amundsen.
Thank you. Before I start, a quick introduction of me. Let me just share my screen. Can you just see my screen?
Yep.
Good. So hello everyone, I am Palash. I expert worker, joined Rapido this year. Joined as a data engineer. Basically, I'm a polyglot developer. Love to work in languages. Introducing about Rapido. Rapido is a bike taxi service. To be honest, it's India's largest bike taxi provider. Very similar to Lyft. We have maybe B2C and B2B customer groups. I hope that was a quick and short introduction. Let me just start on the presentation. Okay, so this one is actually I have copied from one of the presentations that I used for a showcase internally in the organization. So it's, just copy pasting. So please forgive if you find something redundant and unnecessary on this. Quickly going through the problems that why even we needed a catalog software like Amundsen, or maybe why we chose Amundsen. So the problems we faced that inside our entire organization, we wanted to find information about data like customers, various information like last price or quarter, like other attributes about customers' daily events like daily revenue or something else. Similarly, when they know a table name and table name is a little bit tricky, they want to know what's exactly inside the table, what data it is holding. Same goes for the columns as well. Then for the people who are very much interested in querying the data, but querying a fast manner, they need to know what are the partition columns for it. Then someone wants to know, okay, I have a table, I see the data, but I want to know how fresh the data is and how reliable is it. Does it have any anomalies or when this table is updated? Then comes one of the biggest problem into our organization, which is like we have some KPIs and metrics. Quick example could be a tax computation thing. When it's a simple percentage, everyone knows, okay, it's flat 14% or flat 20%. But if it's a complicated formula, same goes for other metrics as well. There should be a single source of truth. And how can we make that happen? So when we have no catalog at all, we are have no clue how to even implement that. Now we have the catalog. I'll show you in the next slide how this can be achieved using Amundsen and Atlas. Next set of problems where we'll be finding the relationships, which is from a view, what is its parent table. Then we have a table where the data is actually stored, because more like a hyper-pesto table, and there is an underlying data source. Then who is the owner of the table, which job updates the table, and tables are updated on a daily basis. That's basically a D-1 table. Then all the views on top of it should also show 24 hours data. It is like a metadata or information propagating from one entity to another entity. The next set of problems were outrages or incidents. So something happened, something bad and really bad happened, and we want to know what is the damage surface. Let's say we used to have a table and that is not getting updated or failing permission. So what are the jobs that we need to retrigger? What are the dashboards that are showing incorrect data or stale data? What are the ML flows that are now producing integration because of the state data, and which all teams and users need to be modified. It could not go through an entire organization wide mail that, hey, we are down with some table. It is not even bothering the target audience at all. Yeah, then there comes this challenge, like we have a lot of tables now, we want to duplicate one of the tables. How can we show sure what are the damages that it is going to do, who are relying on this table. So those were the mainly problems, couple of three big umbrellas. And yeah, next part is the metadata. In our definition, we call it data about data, and we also believe that metadata is not about only your jobs or your tables or views. It's more like for everything you see, every entity, every component, including teams and users. So in the next picture, I will show some of the relationships like between database, schema, table, and also how things are related to user. I'm sure this community must be pretty much familiar with those concepts. Now, these are the features and offerings that we have currently implemented. And yeah, so I'll quickly move into the next slide and tell you the story why we chose Amundsen Atlas combination of these two softwares over other software. So basically, it's pretty much the same features that I was showing in the last slide. And now you see we have those features. Not all of the solutions do support those features, and those are like the immediate requirement for us. Without those, we cannot leave. Search is something which most of the software implemented, and we actually gone through very thorough and deep spice on each of those softwares. We tried every one of those, and we found their own problems. Auto ingest is something like at least table names, tables, metadata, the columns and other information apart from the textual description. Can we have it ready in catalog without any manual intervention or any organic interactions? Uh, then we needed good integration with Apache Atlas for their metadata. We also needed pretty good access control. Then there were like requirements like pass-through entity type, and then comes to very important part of today's catalog related topics, that is table level lineage and column level lineage, which unfortunately at least we found only Atlas supports completely. Even Lineage's DataHub doesn't have column level lineage support yet. Then, since our organization uses Metabase as a utility for data lookup and exploration, also to create a dashboard, we needed a good integration with Metabase. And yeah, the data health report and badges which will be shown on the catalog content, whatever we are going to deliver to all the employees of the organization. So, as you can see, Amundsen and Cluster combination have all of those points available in it. So we have chosen Amundsen. Any questions so far? Or am I good to go?
Yeah, keep going. I would say take the questions at the end.
Okay, cool. That is okay. Cool. Apache Atlas, many represent Apache Atlas as a data governance software, data catalog software. At least from my perspective, I call it a metadata database. What are the similarities with the database and Apache Atlas? So, like, we have similarities on entities relationships, like we have in any RDMS, we have tables and keys. Then we have DDL, which is data definition language. Here we have the definition, entity relationship, classification, and type. Similarly, we manipulate data by DML queries like insert into update. For entities, those are just resources and can be manipulated easily using card. And on top of that, we also have a very good migration system for those entities. So that's pretty much our description of Apache Atlas. Now going to Amundsen. Since we have got the database of our system now, we also need a pretty good UI which represents those information in a valuable manner, which is pretty easy to use for everyone, not only for technical people of the organization, also for the people who are not so much technical, they are just looking for data. And it also gives you very easy interface to edit or update the metadata, which on today's data atlas is lagging. Next, I will show you one of the screenshots that of our Amundsen deployment. So as you can see, it's a pretty familiar screenshot of Amundsen. What we have extra here is those programmatic descriptions on the left bottom corner. We have integrated with it with Metabase. So we are like creating hyperlinks to jump to the Metabase. And people who have access, they can obviously visit Metabase and start querying the table. They can create visualization there. We also have one interactive chart on the data health for last 15 days of this particular table, which is again not same for all the tables. So our implementation consists something like whoever is the owner of the table, whoever is owner of the data set, we define the chart and we have some automatic ingestion techniques which will pick up the chart and display it here as item instead of hard, just image or hard-coded PNG snapshot. So yeah, you can interact with this chart. You can actually change the visualization and see what all anomalies. You can even zoom in or zoom out and find where exactly those anomalies happen on the data. And since it's like up to the owner of the dataset, everyone can implement their own way of charts. Then very quick bar level architecture. So how we are doing all those ingestions into our system. So since I already told you the Apache Atlas is playing the role of metadata database in our system, we need to ingest all those things into Apache Atlas. We initially started with Amundsen native, which is Neo4j and Elasticsearch. We found a couple of problems there, so we moved to this thing. Here, like we have a high metastore as part of that H catalog thing. Both Presto and Hive is connecting to that. Any kind of DDL going through it is getting ingested directly to Atlas. The communication is over Kafka topics. It's not REST, so there is no dependency. There is no blocking on the successful updation of metadata on Apache Atlas. Apache Atlas gets to know about the tables, the views, what are the storage locations, I mean the DCS or the parts of those tables. Similarly, we also have integrated Apache Airflow with Atlas with the Lineage plugins that are available for 1.10.9. It's very unfortunate to say that 1.10.11 the plugins are removed now. But yeah, right now at least we know about all our DAGs, we know the inlets and outlets of each of the DAGs. We also integrated Ranger with Apache Atlas, which is readily available through plugins. So our metadata is going, any changes to metadata is going through proper audit, and that audit is backfed into Apache Atlas. The challenging part was this particular thing, Amundsen to Apache Atlas integration, where we needed access control. Because Amundsen from very beginning it was using a basic authentication from Amundsen to Atlas. It is very difficult to identify who is the user who is triggering this particular metadata operation on Atlas, who is working on Amundsen. So we added some patch, I will come to that later, which is basically using a JWT from Amundsen and forwarding it to Atlas, and that's how we are recognizing the user, that's how we're doing the entire access control. For similar JWTs, we have integrated both Atlas and Amundsen to our organization's keycloak, which is again using Google as the identity provider. Yeah, that's like pretty much very high, top level overview of the architecture. moving to the next, so it's basically a ranger admin way. So far we have those permissions available on particular entity. There are other couple of other permissions available as for admin operations like admin purge, admin delete, admin import and export. Those are not there, but you can find it on the internet. Then what we are offering to our data science teams. So one of the biggest challenges with any data-driven organization is visibility to the email flows. You have a job, you can find some documents, and you have some email flows. Those flows are created very quickly and then productionized very rapidly. You even don't get time to create some kind of documents on top of it, where everybody can understand. Okay, what are the data is getting used, what flows are there, how the model is used, what are the input parameters and output parameters. So we have work in progress situation where we are trying to show those on Apache Atlas. Next part is a catalog client, which is providing us abstract and fast connection to data source. This is very similar to Amazon Glue, where you just tell the name of a table or view and don't even worry. I'll give details on each of the points. So even so, this is again some copied image from I guess Cloudera, but yeah. So this image shows how typical image flows are designed, how is it shown in Apache Atlas Lineage model, and this is our in-house product, which is the catalog client, which I was referring previously. So the facilities it is providing is you get the reference to a particular table or field. Now let's say you have a job which fires a Presto query, it utilizes the entire Presto cluster, uses it, and then gets the data into Spark and then processes further. Now, while the Presto is running, you still have a Spark cluster Apui with maybe Datapop Spark, and that is just wasted of money because your entire Spark cluster is idle. Also, you are spending money in two places. You are spending money on Presto for execution, you are spending money on Spark for execution. How this client will solve it? It basically reads the catalog, doesn't even touch Presto. It will never let the user or the actual program know what is happening underneath. It just totally abstracts the entire concept. What it does is basically understand the SQL, parses the SQL, converts it into Spark SQL, and then directly starts reading the GCS paths. That's how we implemented, and we cut down Presto altogether from the path. Another important part is this partition updation of table, which is when we are writing a job which is going to update the partition of a particular table, we also need to know what is the underlying path where the data is stored. Now with this utility, since the source of truth for a table is already there in the system, it is in high meta store as well as it is propagated to catalog, with help of that information, we can simply say, okay, just add those permissions. You already know where the data is stored. You already know how to construct the partition path. So that's how this made our life easy. Also saved us from a lot of inconsistencies. Then comes the pairing points. What we faced. Why it took almost 1.5 months to come to state right now we have in Amundsen and Atlas, and why it took so long. Some of the pain points which are even not solved today is we have some places where Atlas proxy is not as good as the implementation of basic implementation in Neo4j or Lineage. So we have some of the features which are not implemented. We have some of the features which are broken on Atlas proxy. Then next part is mutable Docker. So in the audience, if anyone is planning to start with Amundsen and they want to use a Docker-based system like either a Docker Compose or even with this, then I would suggest that you go just one tag before the current tag, because CI/CD system is really great with Amundsen, but it has only one problem. it continuously pushes on the last tag as well as the latest tag. So what happened one day, I took pull up one of the tags, let's say that was 2.3.1, and then I was working after half an hour and all, I ran some code and then I found it is not working anymore. What actually happened, I checked into Docker and I found 8 minutes ago there is a new push on the same tag. So yeah, then the plugin support. So we always wanted to get rid of having a fork of Amundsen. We never wanted to get involved into the source code. Rather, we started, raising the issues on Amundsen GitHub repo, and we wanted to contribute in the way that we don't keep anything with us inside Rapido. It's good to have everything contributed directly on Amundsen. So in case we have some kind of organization specific needs, it is very difficult to implement that without changing the code. So somehow at least I felt that we have a lack of plugin support, and like we have to mount some Python files, we have to edit some Python files and put it there. Next part is some minor markdown integration problem. We found the error handling on UI not that good. At least for me it is okay, but for the end users who are like, it is only showing me something went wrong. Sometimes they are searching, even the token got expired from backend side, and they are not even knowing there is some error is happening. So the exceptions are getting eaten in the front end code. Search is something everybody complains a lot, especially they want to search on the description of the columns. Quick example could be, I want to know the daily revenue, which are columns and tables hold the data. So if I search daily revenue, and let's say that is not part of any of the tables description, then it is not searchable today. Based on the column name also, the search is not good with Atlas based proxy. That's the Amundsen Atlas integration problem. One of the biggest challenge that we face today is the memory management. Since like all Java apps and all, they have a heap memory control on it. So you can limit the total heap memory. You can say when to stop and start garbage collection. I don't find the same feature in Amundsen apps. And what happens in metadata apps sometimes, eats up a lot of memory and then it doesn't release those memories. Yeah, next is the challenges, which is authorization file ranger, which we already solved and I explained last. Then we have the biggest challenge, our biggest challenge is page to views, which is like we are using high hook at first, but that doesn't capture the page to views. Then we started using high metastore hook, and eventually found that high metastore hook was so much influenced from Impala. And the contributors who actually created those, they had always the Impala thing floating on their mind while creating that. So it has various, what to say, not completely not implementation of testo related features. So we had to patch something to give support to those. So we are like now done with up to the table lineage. So column lineage is the last part which we are lacking. And so much important thing, that is a backup and restore of metadata. Again, in the audience, if anyone uses Atlas, and I would like to warn them that if you drop a view and recreate the view, Atlas removes all your column descriptions as well as table descriptions. So please be aware of it. Implement your own backup restore system. We right now is using a Google Sheet to feed all the column descriptions, and whenever something is lost, we just run a very Node.js script which utilizes the Amundsen metadata API and ingest all the description into it. Some of the patches out there, we are using Kubernetes Helm deployment, but we are not using the official Helm charts. We created our own, and yeah, as you can see, we have implemented some hacks to implement those patches. They basically on the fly modifies the Python files using some save commands. And this is one of the reasons why we don't want to contribute back these stupid hacks back into Amundsen. We want things to be developed in proper way, in correct way. Those are the patches in Atlas which we had to do to give support of rest of view parsing in 875 metastore hook. Key working projects and the future of our journey in Amundsen Atlas. Well, obviously, database integration is done up to some extent. We got the links, we got the help charts. We still need to work on the dashboard support because we know Amundsen has very good dashboard support. It's more like examples are with mode, but we want to do the same with database. Presto view support is like almost complete now, but we are lagging on the column Lineage part. Park job integration, this is also important. Like if you have a job, it uses some kind of logic. The logic must be captured someone in catalog. Also, Spark should be able to grab any kind of API or metric formulas from catalog. For example, tax computation. Next part is masking PIA based on tags. So this on the Google Sheet we already asked our users whoever is updating the catalog information, we ask them to whenever you are adding description of a column, please mark if it is a PIA or not. We believe since Atlas supports classification or tags for individual columns, we believe it will be supported soon in Amundsen as well. This is very important feature because we are a data-driven company. We hold a lot of PIA, personal information of customers as well as our employees who are the captains or the riders of the bike taxi. So point is, if you don't mark the PIIs, it is very difficult to at least identify those, protect those from the bigger audience, and mask those out. So there is a very good integration between Apache Atlas and Ranger, where Ranger utilizes those tags from Apache Atlas, and then we can create tag-based policies which will mark mask the PIA information on those columns or maybe Kafka topic, anything, any kind of metadata. It will, if the plugin is there, it will just mask the data out. Yeah, that's like the end of big slide. Now we can shoot questions.
Cool, thank you, Palash. We have a lot of great questions. We're going to start with Verdan. Verdan, do you want to ask your questions?
Yeah, sure. So the first one is that do you use Atlas tags to apply the Apache Ranger policies? Because you are not in between Atlas and Ranger. Do you use the tags?
Not yet. That integration is not done, but in future we will do that.
Okay. And any plans to upstream your void you did for the access control, like passing the JWT to Apache Atlas? And
yeah, that is in place. That is done. So that was like a big challenge for us, and one of the reasons why we kept our Amundsen deployment inside our VPN for so long. But that part is done, and now we are like forwarding the JWT tokens to Atlas. Unfortunately, since we are lacking a little bit of error message handling on Amundsen content, when there is like some access control error happens on Atlas layer, we don't get to know that, okay, it is a 403 forbidden kind of thing. We get something with wrong error message. But access control is done, audit logs are there. We get to know who is editing those, who is visiting those metadata entities.
No, but do you have any plans to upstream that work?
Upstream to?
To the GitHub, to the actual repository of Amundsen with the documentation. How did you do that so that other people can actually follow the same?
So my personal opinion would be we develop it in the correct way. Maybe we can open a ticket and discuss it there. Right now, I will tell you how I implemented it. I just used some kind of fast hacks, which is like getting the headers from request context, and I edited that into the Atlas client because Amundsen uses basically the Atlas client underneath, and I edited the Atlas client altogether, which is capturing the JWT from the headers of the Flask app, which is the Amundsen app. So it needs involvement, it needs participation from both the repository, Atlas client, PyAtlas client, as well as Amundsen. So yeah, we need to create tickets for those, and we need to implement it properly.
All right. So the PyAtlas client is, I'm kind of maintainer for that PyAtlas client, so it would be nice if you can open up the pull request for that, so that we can actually help the community with the work that you guys are doing. Otherwise, it would be just you guys, and then we won't be able to get all the support from you. So it would be nice if you can do that.
Yeah, sure.
Thanks.
I got it. I created tickets on both the sides. And also I would like to mention that the way we did it is a very mere hack. In actual implementation, this will need a lot of changes on Amundsen system because you have to like flow the header from top to bottom, from your request to your repository layer, that is the proxy layer. What I did, I used some kind of black magic, like getting it out from the context. So maybe we can discuss it more on the GitHub tickets.
Cool. Thank you. Next question, Madison, do you want to ask yours?
Yeah, sure. You talked a bit about the role-based access control. Is that done just in Atlas, or is that Can you talk a bit more about that integration with Amundsen?
Yeah, so it's basically in Atlas, and Amundsen is just delegating the user from Amundsen UI to the Atlas. And since it's JWT, it's already secure, we handle the authentication part individually on Atlas as well as Amundsen. The authorization part happens on Atlas because we have all the policies ready. We know individual user's role, and we can decide whether he or she has access to some metadata entity or not.
Cool, thank you. In interest of time, I'm going to request the other questions to be handled later in direct message. So thank you, Palash, for coming today, and looking forward to more contributions to Amundsen.
Yeah, thank you.
Cool. Daniel, do you want to go next and talk about Lineage?
Sure. Let me try to do this relatively quickly. Can everyone see my screen?
Yep.
Okay, cool. So basically, we're working on building Lineage features into Amundsen. I know this is one of the most requested features. So I want to go over some of the preliminary research work that we've been doing. A little bit of background. Data lineage is a very broad term, and you can't build everything, at least not right now. So we need to identify the core set of features that we want to build. And so what we need to identify whatever has the highest return on investment. We're targeting data modelers, which are like data scientists and data engineers, and then researchers, which include data scientists and analysts. And those are the key personas that we're targeting with this work initially. And so let's go over some of the use cases that we found. One of the number one use cases was finding the root cause of an issue. This is both for engineers and scientists. So let's say there's a broken metric or a value that looks weird. It's like 3 standard deviations off of normal. You have missing data or an ETL job failed. You have to track down what is the root cause of this issue. And that often takes you to Lineage, where you need to see like where did this data come from. Okay, this came from this ETL job, came from this table, and you have to trace it back up upstream. And hopefully you can find a problem. The second use case that we found was when you're building a data set or a report, you need to know, is this the right column or table to use? Where is this calculated or computed? Can I see the raw SQL that generated this? And then like, where is the original source for this data? And should I be using that instead? Or is there a different source that I should be using? And this applies for both data engineers, data modelers, researchers, and engineers. And then the third use case that we found was notifying downstream owners. So it's kind of the opposite, where you have an outage, either planned or unplanned, or a definition change or a deprecation, and you need to tell people that their resources are going to be affected. And if you don't tell them, then their stuff will just suddenly break without warning. So you need to figure out who those owners are. And right now, people usually message them specifically, or they spam like the all email listing or data listing or @here on various Slack channels. Basically, just like loudspeaker that this change is coming. And it's up to the owners to listen to those. That can be quite a challenge there as well. This is kind of a more niche use case where a data modeler might come in and look at a table and see like how is this being used? And if no one's using it, can we deprecate it? Can we delete it? This costs money. How can we save money? Are we building things that no one uses, right? And if you have complete lineage, you can very easily tell if no one's using something. And then this is kind of similar to the previous one, but it's for, like, let's say you build a new data set or pipeline, and you want to track adoption across your org. And one quick way to find out is to see, like, are there other jobs that use this data set or other data sets that use this. So this can be like a success metric for a team who's supposed to build out a new pipeline. And then we have some pain points. I'm sure all of you probably are aware of some of these, at least. At least for Lyft, a data lineage lives in multiple tools, and tracking down this one table can be very painful. So here's a typical use case. You go to Amundsen and you find the table that has the issue. And then you click on the Airflow link, and then you see the job. Is there anything wrong with the job? No, everything looks normal. Okay, then you go back to Amundsen, click on the compiler works link, find the upstream table of that, find the Amundsen listing for that upstream table. Then you go back to Airflow and check the status of the bag, see if there's anything wrong. And then you basically rinse and repeat, and you go up the chain until you find where the issue is found. This is extremely painful. The second one I mentioned earlier is about missed communication. So in the case where there is a change that you did not hear about, or maybe they didn't tell you about, or you missed the email, this can cause a failure in your data set or your report or your DAG or whatever. And if this is a loud failure where you get an on-call page, someone will take care of it, right? That's painful, but it's not too bad. The worst case is when you have a quiet failure where all the jobs quietly pass and you didn't set up your testing, you didn't set up your criteria for like success metrics for the job, and you have no learning for this. You end up with bad data that just quietly gets passed along, and then maybe someone is looking at that data and makes a decision based on some wrong data, or even like an ML model, which will like automatically just make these decisions without telling anyone. And this type of failure can cost millions of dollars. Detection can take weeks or even months, and finding the root cause can be very tricky. This is probably one of the most painful points of this. And then also, the lineage graph is often complex, not as a fault of the lineage graph itself, but just the data model itself is very complex, and it's hard to navigate, and it's hard to read. And we found that oftentimes our users, despite having access to these tools, such as CompilerWorks, they shy away because they look at this and they say, wow, I can't read this, this is too much. And they get intimidated and they find other ways, simpler ways to find out what they're looking for, or they just avoid this workflow altogether. Although there are some power users who love this and know how to navigate this. I think the complexity here is just too much. Some other findings that we have from our interviews is that column lineage is much more interesting than table level lineage, and the table lineage by itself is useful, but it's not super interesting. The cases we have are based around columns, like specific columns failing or specific metrics changing on a column. And the second thing that we learned is, and maybe this is really obvious, but less is more. The presentation of this information is extremely important, and we need to make this easy to digest. And some users even suggested a simple listing of upstream tables and downstream tables and would be useful as an MVP. And then finally, next steps. We are probably going to target, we need to choose which use cases to target, and the candidates right now are 1, 2, and 3. So that was identifying the root cause of an issue, building a data set or report, and then notifying downstream owners. And next on my plate is to write a PRD and collect feedback, and then work with design to come up with how this feature will look like in the UI. Now I'll open it up to questions.
Cool. I see a comment from Gerald and a question from Gary. Maybe Gerald, do you want to share your comment first?
Yeah, this is Gerald from CompilerWorks. I'm not sure if everyone here knows what we do, but we take the logs from all your data repositories and we build column level lineage. And Lyft is using our software, and this is great feedback, Dan. You've got problems. At the moment, we've spent a lot of time building that model, but if you can tell us what you want exposed in the user interface, at the moment we have a GraphQL API that can answer any question you have, but we need to know the problems you have, and we will build that into the user interface for you.
Yep, there's quite a lot of information there. I don't know how in depth we can go. The feedback that I've heard from users is, number one, it's too small, and even with the zooming in, there's basically the graph is just too big, and then all the font size gets too shrunk. And they get overwhelmed. And we can take this offline.
We'll take it offline. Yeah, thanks.
Yeah. Gary, do you want to go next? Hey, your mic's not working. So maybe I can ask the question on Gary's behalf. And he's wondering what your thoughts are on lineage collection, Daniel.
Lineage collection, that's a hard problem, and there are companies like CompilerWorks that tackle this hard problem. I think ideally we would want to build an open source solution for this and provide it to Amundsen as a feature of Amundsen. Alternative is to leverage another tool that generates the lineage information and ingest that as another ingestion framework that we have.
Is the mic working? No.
So I could comment a bit on this one. So I think the user study here is that we want to aim like we have a single portal to have the experience for both the metadata explorer that we have currently for us as well as the Linux explorations. So how people collect it will be different. If they use compiler, could collect from CompilerWorks, or then if they use Hive, for example, Hive lineage, like what Atlas or wherever, they already provide a Hive lineage, could expose from that side. Or if they have a way, for example, like Airflow, they have a lineage client, they could, if you integrate with the lineage client, you could kind of even like combine both the DAG task level as well as the input data set as well as output data set. That's another front. Or if you have your own set of query log, for example, you could easily build your own parsing. For example, at Lyft, we have our own query log, including some additional field, like say which task they're using this one. You could easily have build your own parsing to get that. That's a few different options I could think of based on different environment.
Yeah, you can hear me now?
Yeah, it's a little muffled.
Okay, I'm not sure what's going on. I guess it's my computer. I might follow up online, offline. I think it's an interesting topic because I think there's I see four options at the time. You're actually creating your pipeline to create it, maybe after the fact as part of documentation. Possibly inferring it from the code, but that's, there's many different types of code, and then maybe inferring it from the actual data, so you're trying to look into data sets and associating lineage. So I'd be interested if there's an offline conversation with your things we can talk about.
Okay, thanks, Gary.
You are mute, Mark.
Oh, good segue to turn on to Verdan, who's already presenting a screen on Lineage and Atlas. So go for it, Verdan.
Perfect. So I only have like 10 minutes, so I won't go into details. I don't really have a fancy presentation and also not the complex lineage graphs that Daniel just showed. So I would start simple. I would be using the dummy data for Atlas, which they provide by default. And so in Atlas, lineage helps you understand the source and impact of data, and also the changes to data over time. So essentially, if you want to summarize this, the lineage information helps you understand the origin of the data and the transformation it may have gone through before arriving in a file or a table. So that's the lineage concept, and the whole lineage relationships in Atlas is stored as the vertex in Atlas graphs database. And when you click on the table detail page or any of the data source detail page, it is then displayed as the lineage graph. Let's take this example here. You see, this is a complete lineage graph, and this is the daily MB table. Let's say like on the daily basis, this starts, and then there's a certain process, and then after that, it moves to the monthly table, right? Um, so full lineage information has two concepts in Atlas, the lineage and the impact. Can you guys see my cursor? Perfect. So in Atlas, it has two main concepts like lineage and the impact. So lineage essentially is the upstream part, and the impact is the downstream part. That means that when we're talking about the lineage, I would go to the other table. Yeah. Now we have the lineage and plus the impact both. So upstream part, what does that mean? What do I mean by the upstream part? That's the path to the current data source passing through all the other data sources and the process. That means that where does this data originated from? This is the lineage information, right? And the impact is the downstream part, that this table impacts this table, path out of current data source, passing from all data assets and the processes. And you see this circle, this represents the current entity on which I am at the moment. So this basically this one, sales spec daily MB. The good points about the Atlas lineage is that you can hover over and then immediately before and after those entities will be highlighted. And the other thing that also Palash mentioned in the chat, that you can filter out based on the depth, so you can definitely minimize the noise in the lineage graph. It also has the option to hide the processes and only talk about the entities like the tables or the comments level. You can also hide the deleted entities if you want to. And of course, you can zoom in, you can drag drop based on your own things, and then you can easily reset that. That's the Atlas UI for the lineage. And of course, Atlas provides the REST APIs to play around with this whole lineage information, and then you can expose this lineage information to Amundsen. Yeah, that's also an added advantage. That's it from the UI demo.
Good. Laurent, you have a question here?
Yeah, my question was, things change, that lineage constantly change. You push a new version of code, you change the schema, even the shape of the graph is changing. So how do you keep that updated as it changes?
Yeah, Palash already answered your question, because Atlas has the hooks and bridges, which is connected to the different data sources, Kafka and other things. So it automatically generates the new lineage information based on those notifications or messages. So every time the table is dropped or schema is changed or the new views are created, it would record the lineage information in a Atlas graph database.
But you do have to hook with all your system through Kafka, basically, to capture that information. And then Atlas will update.
Yes.
So I have a question. What I know Hive provide this hook. What if the system doesn't have this kind of hook for the lineage information? How do you capture that in this case?
Yeah, I don't really have the understanding of the complete information and of the complete system. I think Mariusz, are you on the call? Can you answer this one?
Yes. Can you hear me well?
Yes.
So what Verdan showed is basically the lineage consisting of table objects, but also in between entities called processes. And in this case, when a table appears, so the blue entities, blue icons, is basically coming from probably Hive hook. This is a listener capturing all the events in Hive metastore, converting them into Atlas entities and sending to Kafka topic from which Atlas consumes it. And those processes in between, so the green icons with the these ones, probably this is the one way you can create such an entry is through Spark Atlas Connector, which is a library you can connect to your Spark application that would create such an entry. Unfortunately, Spark Atlas Connector is a project that it's not longer supported, and we are using our internally hacked version that is able to run partially with Spark Free, but it's more or less, it's safe to assume dead. No one really develops it anymore, but this kind of utility running alongside your Spark application is one way to capture these processes.
So I guess the question I should have two questions. First is like, for example, for Redshift, I'm not sure, but I assume they don't have the hook to expose the lineage information that you could build the Atlas integration with Redshift. In this case, you cannot capture lineage if you are using Redshift through this mechanism. Second is that I know Bokeh, I'm not sure he's here. He built a lineage, the whole lineage interface in Airflow upstream. In ING, do you using that to capture the job as well as the input-output data sets in this case? Yeah, that's the two questions.
So starting from the second one, because that's, I guess, easier for me to answer. So far, we've been only using Spark Atlas Connector to capture processes. So we are yet to start using inlets and outlets, because I think that's the name of the lineage components in Airflow Bokeh has been working on. That's one thing. I think second one is that it's not, it's a voluntary thing to use them. So in our applications we can use them, but the challenge we have faced and not solved yet is how to, for example, enforce that every application running on Spark has this Spark Atlas connector, because it is connected actually on the client side, on the application side, not on the server, Spark server side. So even though I can run my applications with Spark Atlas connector, someone can skip this part and do not use it. So this was the challenge we noted, but have yet to solve. And as part as the Redshift goes, I'm not sure if there is a hook, and if it's not there, then I guess you're right that the lineage wouldn't be captured.
So we might want to maybe discuss a little bit, because we are working on Marquez on our side, and we are working on a Spark adapter that hooks into the internals of Spark and extract the lineage information as basically the Spark jobs are being scheduled. So.
Cool. Palash, do you want to ask your question?
Sure. So one of the challenges that I see from the lineage model of Atlas is it's more related to the column lineage actually. The first question is, when we have a view, we say that select star from raw table, and when you do an altered operation on the underlying table, you add a column, you remove a column, how the final view gets changed. So far, like in case of our organization, our views are mostly Presto views. And what happens when you change the table, the Presto view also gets changed. So the hook already intimates that, hook already informs that. But in case of systems where such events don't appear on changes of table, the views are not changed, how can we solve that problem? Does that make my question clear? Little clear for you?
Yeah, it doesn't seem like people have it was immediately. So maybe that could be something we follow up offline. We're also at the hour.
Okay. And the second question is very simple. It's already there on Cloudera and HTTP. Like when we delete one of the, even if you can try deleting one of the downstreams on your Atlas. So for the current version, doesn't delete the processes, and the process keeps hanging on the Lineage UI.
So this is by design in Atlas. So if you would ask this question with the Atlas community, they would simply reply that they don't really want to delete the entities, any kind of entities from the Atlas. That's their design decisions. So that in the future you can see the complete lineage even if it is deleted. So you can hide the deleted entities on the lineage information by the filter, but you can't delete completely from the lineage.
Okay.
One point on the.
I'm gonna have to cut this off. I know Marcus has something he wants to bring up, and then Palash and Verdan, you can follow up offline on that. Is that okay?
Sure.
Yeah. So one thing, just super quick. Today started in October, and there's this event that's called Hacktoberfest. It's a way of trying to develop open source, and the idea is that basically it's DigitalOcean and GitHub contributing, and basically if people send a number of PRs to open source projects, they will just gonna get a t-shirt, or they're gonna get some trees planted. So the idea is that basically open source projects will tag some issues as Hacktoberfest, and I just did that with our good first issues in our repo, and then people can just send PRs for that and then just qualify for getting those prizes. So I just want you to ask you to just promote this. I'll send you a link of those tags, so if you can just share it on your social media or in your company, that would be great, and trying to get a little bit more of momentum on it.
Cool. Thank you. I know we are over time, and I know there are questions and comments that we didn't cover, and I apologize for cutting off that. But thank you all for joining. We see you in another month and hope for a new set of amazing content and discussion then. Thank you to the speakers, Palash, Verdan, and Daniel for presenting their work too. Thank you so much.
Thank you all.
Thank you. See you.
Thanks. Have a nice one.
Bye.
Thanks.